Let's look at another problem where we need to find the perimeter of some polygon on the coordinate plane. And remember, perimeter, that's just the length around the outside of our shape. And in this case, we're looking at the length around this triangle. And the general strategy is that we can either use the distance formula to find these lengths, or we can just create right triangles and use the Pythagorean theorem. So let's go with that approach. Let's just make some right triangles here. And we do that with just vertical and horizontal lines. And we can count the side lengths now, just the number of boxes. This has length 2, and this has length 2. And this is a right triangle. So we'll call this C1, since we generally use C for the hypotenuse in the Pythagorean theorem. And this is our first side length we want to find. So we want to use our Pythagorean theorem, and we know that's just a squared plus b squared is equal to c squared in some right triangle, where a and b are the legs of the triangle, and c is the long side, the hypotenuse. So let's plug these in. We would have 2 squared plus 2 squared is equal to c sub 1 squared. So this is 4, this is 4 as well, and simplifying we get 8, or we really want to write it as 2 times 4, since we're going to take a square root of everything. So we get the square root of 8, and the square root of 8, if we write it as 2 times 4, we can actually simplify this. Since 4 is a perfect square, if we take that square root, we will actually get a whole number. So separating this into 2 square roots, we get root 2 times by root 4, and root 4, like I mentioned, that's just a whole number. That's equal to 2. So this is 2 times the square root of 2. So we found one of our lengths, and now we just got to find the other two. So let's again decompose this into a right triangle. Or like I mentioned, you can use the distance formula, but this is in a lot of ways a more visual method. So then you're not just memorizing a formula. So we again have this right triangle, and we want to count the side lengths. So 1, 2, 3, 4, 5. So this is length 5, and this one is 1, 2, 3, 4, 5, 6, 7. So if we call this C2, we can figure that out now. So the hypotenuse squared is equal to the 2 legs squared and added together. And this is 25 plus 49. And if we add those together, if we add 20, that brings us to 69, and 5 more brings us to 74. So taking a square root of each side, we get the square root of 74. And we could try to simplify this, but this is twice 37. And 37 is a prime number, and 2 is a prime number, and neither of those are paired up, so we don't have any perfect squares. And in fact, in this problem, since we're going to find a decimal answer, it's not completely important to simplify it. It just helps to get a little practice, because in some problems you will need to simplify this. So we can just leave this as our answer for C2. And we just need to find one more side. We can call this C sub 3 and break this one up into a right triangle so that we can find the hypotenuse. So let's count. This is 1, 2, 3, 4, 5 long, and this is 1, 2, 3, 4, 5, 6, 7. So that's convenient for us because it's the same triangle here. So right away, we will end up with this exact same scenario, except we'd have c sub 3 squared. But this is also going to be the square root of 74. So our perimeter of this triangle here, we just add all 3 of these lengths together, and we get 2 times the square root of 2 plus root 74 plus root 74, or 2 times by the square root of 74. And at this point, we want an approximate answer so that we can choose which of these 4 choices is the correct choice. So we'll need to plug this into our calculator and then round it, it looks like, to the 10th place. And after you plug this in, what you get is 20.033, and then it's going to go on forever since it's irrational. but that will just round to 20.0. So in this case, it looks like choice A is the correct answer.